Hello friends, this is Anmesh and welcome to the Gate Mantra. So from last video we are practicing the question here and we have seen around 3 questions in the last video. In this video we are going to start with a new question that's given in the Gate 2018 where it's given the 2 marks and the input of the marks is given. Here the VCC is logic 1 and ground is logic 0 and the output of the mux 1 is given as an input to the mux 2. Okay, mux 2 where I0 I1 is connected to the output of the mux 1 and I2 I3 is connected to the ground. Here the selective line is given as U and V. Here the selective line is given for the mux 2 is W and X. Okay, and here it's asking for the function, that what will be the our boolean expression for our output function. So the question is given, it's properly mentioned that a 4 variable boolean function is realized, okay, using the 4 to 1 mux as shown in the figure below. So we have to find this output, okay, output that will be the function of the 4 variable u, v, w, x. Okay, right. So as we know that for the mux, if there will be the mux, okay, if there will be the mux, okay, of 4 to 1 of 4 to 1 mux, and this will be the input I0 I1 I2 and the I3, and this will be the selective line S1 and S0. Then here the boolean expression for the y, okay, the output will be S1 bar S0 bar I0 plus S1 bar S0 I1 plus S1 S0 bar I2 and plus S1 S0 I3. Okay, we have seen this in our first class, okay, of the mux, the output of the y. So similarly we are going to find the output like this for both these two mux. Okay, so I am considering the any value p here, okay, the p here. Okay, so what will be the expression for the p, what will be the expression for the p? Okay, leave it here. Here what will be the expression of the p? The p will be equal to okay, u bar v bar into 0 because it is grounded, plus u bar v into 1 plus u v bar into 1 and plus u v, okay, this is the v, u and the v and the 0. Okay, now when we are giving the 0 input here, okay, when u equal to 0 and v will be equal to 0, then I0 will be selected and I0 will be present at the output. When uv will be equal to the 0 1, then I1 will be selected. When uv equal to 1 0, then the I2 will be selected, and when uv equal to 1 1, then the I3 will be selected. So we have written the boolean expression for the output, okay, output of the first mux. Okay, so here we are seeing that p will be equal to, this will be equal to 0, then u bar v plus u v bar, okay, that is u XOR v. Now we are going to find the output expression, okay, output boolean expression for the mux 2. Okay, this one for the mux 1, this one for the mux 1. Now we are going to find the boolean expression for the mux 2. So for the mux 2, here y will be equal to w bar, okay, x bar, and this is p plus w bar x, and this is again p, and plus w x bar 0 because this is grounded. So when we will put 1 0 here or 0 1 here, okay, when we will put the 1 0 here, 1 0 here or 1 1 here, when we will put the 1 0, the I2 will be selected and I2 is grounded. So for 1 0 the output will be 0, and for the 1 1 again it will select the I3, and I3 is present at the output. So for 1 1 also the output will be 0. Okay, so for wx our output is 0. Now we are going to write this, okay. Then w bar x bar p plus w bar x and p. Now we have take common here, w bar p we have taken the common, and x bar plus x, this will be equal to 1. Then here will be w bar and p. And what is the p? P is equal to u XOR v. So here we will find the function f of a, b and c. Sorry, not it, this is the not a, b, c. This is the u v w x, u v w x as, okay, as u XOR v, okay, and the w bar, and the w bar. So this will be our final answer. This will be our final answer. So here given the 2 marks. Okay, the for first mark the selective line is wv. For the second mark the selective line is wx, and for the first mark the selective line is u and p. For the second marks the selective line is w and x. So we know how to write this expression. Okay, for the different combination of the u and v, we are going to get the output p. Okay, depending upon the different combination of u and v, we are going to get the output p for the given input. Okay, for the given input. So we know that how to find this expression from our first class. So we have found this expression, then we have calculated this. Okay, we have minimized this expression and we have calculated this, and for marks 2 we have find this expression. We know already how to find this one. Okay, then we have minimized this and we have landed up to the this expression for the y, okay, for the y, this is equal to f of u v w x. Okay, this is the f of u v w and x, and finally we are going to get the answer. Okay, so this is a very easy question that asked in the GATE 2018. Okay, now we are going to solve some question, okay, from my side. Okay, before solving the question, please pause your video and please solve it by yourself. If you are unable to solve the question, then see the solution. Okay, first but first please try by yourself. So our next question will be the second question of our today, okay, or this class. Our second question of this class is okay. It's given the 4 to 1 marks. It's given the 4 to 1 marks. Okay. It is given 4 to 1 marks. This is our 4 to 1 marks. Is given the 4 input and given 2 selective line and given the 1 output. It's given the 4 input as C1 0 C bar, C1 0 and C bar, and here it's given the selective line is S1 and the S0, A and the B. Okay, now this is the output. Output is the function of A, B and the C. Of course, output will be the function of the A, B and the C, and it is asking to find the what will be the our output. What will be the our output? So how we are going to solve this type of the problem where the selective line is given and the input is given? Okay, how we are going to find this output expression? So there is 2 methods. Okay, from which we are going to find this expression. Okay, right. So our first method will be the simply we are going to solve this. Simply we are going to write the output of the marks that we are writing in the traditional method. Okay, what will the output? So we have writing here y is equal to a bar, b bar, and I naught, I1, I2, and the I3. Then a bar, b bar, I naught is c here, or write it a bar, b bar, I naught plus a bar, b, I1 plus a b bar, I2 plus a b, I3. Now y will equal to a bar, b bar, and what is I naught c plus a bar, b, and this is 1, I1, and then a b bar, and I2 will be 0. So this will be the equal to the 0. This will be equal to the 0. Okay. Now this a, b, and the c bar, a, b, and c bar. Now we are going to take something common here, or we are going to add his c and plus c bar here, right? Here we are going to add the c and the c bar, or we are going to take something common from this. Okay. So here what we are going to take, here we are going to take y is equal to a b bar, a bar, b bar, c plus here I am going to take the b common. Okay, then here a bar and plus a c bar. Okay, a bar plus a c bar. So from here how we can write here? From here we will write y equal to a bar, b bar, c, and plus b. Okay, and here a bar plus c bar. We will write here, right? We will write like this. Okay, we will write like this, and then we are going to multiply. Okay, y will be equal to a bar, b bar, c plus a bar, b plus a plus b c bar plus b and the c bar. Now from here how we are going to solve? Okay, now from here we are going to take the a bar as a comma, a bar as a comma, a bar. Okay, then b bar, c, and plus b c bar. Now what we will write here? Again y will be equal to a bar. Okay, we have taken a bar common, b bar, c, and plus b. So we can write here b plus c. We can write here b plus c. Okay, we can write here a bar and the b plus c. Okay, and plus b c bar. So we are going to expand this a bar b plus a bar c and plus b c bar. A bar b plus a bar c and plus b c bar. Okay, now what we are going to take common here? A bar b and a bar c and plus a bar b and a bar c and plus a bar c and b c bar. Okay, see here a bar c and the a bar b. So here a bar c, check these two term. Okay, a bar c and the b c. Okay, we have written a bar c and plus b c bar. Okay, and plus a bar b. Okay, concentrate on this a bar c. Okay, and then b C bar, and A bar B will be equal to A bar C and plus B C bar. How? Like this, okay, like this. When we are going to write A bar, A B plus A bar C and plus B C will be equal to A B plus A bar C, right? We first take this, okay, and then here we concentrate on the here A, and then variable A, and is next the complement of variable A and the product of two, this right here. So we are going to minimize this like this, okay. So our final answer will be equal to the y, this one. Then f of A, B and C will be equal to A bar C plus B C bar, right? So see here how lengthy it is, okay. If we are not remembering any means minimization things, okay, then we are going to start this type of the problem. So here we have expressed the output. Now we have take the common here, b common here, we have taken the b common. Now from here we will minimize this into this, okay, this into this a bar plus a c bar, okay, will be equal to the a bar plus c bar, okay. And then again we have taken a bar here, and again we have minimized this into this b plus c, okay. And again here one minimization, okay. So see, if we don't know the how to do the minimization, so we will going to start this type of the problem. And so we have solved this by the first method, okay, by the first method. Now I am going to tell you the second method, how you are going to solve it by the second method. And the second method will be more easy compared to this. So when this type of the problem is asked in the question and we are not comfortable with this minimization, then please go with the second method, because in second method we will solve this, okay, very easily. See how we are going to solve this, okay. First write is I0, I1, I2 and I3. Okay, and write here A, B and C, A, B and C, A, B and C, A, B and C. Like our previous example, we are going to do this, okay. Now our AB as a selective line, so put AB 0 0 0 0 0 1 0 1 1 0 1 0 and 1 1 1 1. Now we are going to put for the C, that will be equal to 0 1, and here 0 1, here 0 1, and here 0 1. Now what we are going to do, okay, so in first input I0 what's given, in first input C is given, so in I0 we are going to group where the C is present. So here C is present, so we have to group this, okay, 0 0 1. So in the second input I1 1 is given, so we have going to group these two, so we are going to get the 1 as an input. In the I2 nothing is given as an input 0, so we are not going to group anything here. In the fourth input is given C bar is the input, so we are going to group the C bar, okay, we are going to group C bar like this, okay. Now what we have writing here, okay, what we have writing here, C summation M of C here, this is the 1, this is the 2, this is the 3, and this is the 6. 1 2 3 and the 6, okay. So here our output will be equal to the summation of 1 2 3 6. Now we are going to write the K map, okay. Here we have written A, here B and C. Okay, here this 0, 1, 3, 2, 4, 5, 7 and 6. Here A bar, A here, B bar, C bar, B bar, C, B, C and B, C bar. Okay, now we are going to fill this. Okay, here I have to fill 1 here, then at 2, then at 3 and then at 6. Now we are going to do the grouping. So we have grouped this here and we have grouped this here. Okay, now what we are going to get, okay, or we will write here the function of A, B, C will be equal to what? This is the A bar and C plus B, C bar. Okay, so this is the easy method through which we can solve the question. Okay, this is the easy method through which we can solve the method. In the earlier method, there will be lots of the Boolean expression. Because of that, there will be lot of the Boolean expression minimization in our previous method, and we don't remember all the minimization. Okay, then we will stuck in between the question. So please, for this type of question, go through this method. In this method, first, how we are going to proceed. So the value given in the question, right? First input I0, I1, I2 and 3, and then A, B, C. Okay, then AB is a selective line, so right, for AB 0 0 0 1 1 0 1 1, here 0 0 0 1 1 0 and 1 1, and right here 0 1 for C, 0 1 0 1 and 0 1. Okay, now see here, the for first input I0, C is given as an input. So for I0, C is given at the input. Here we can write this is the C, here we can write this is the C, and here we can write this is the 1, and here we can write this is the 0, and here we can write this is the C bar. Okay, now we are going to group this, and we have written in the this form. Okay, and now by using the K-map, we are going to find the output. We are going to find the Boolean expression of the output. Okay, this is the easy method, and if we will do practice, we will going to do this very quickly in the examination with 100% accuracy. Accuracy matter in the examination, so you use this method to find the answer. Okay, instead of our first method. And if you are feeling any difficulty in this, please pause the video and replay it. Okay, replay it again, or if again your doubt is not clarified, then please ask me in the Telegram group. Okay, okay, now we are going to solve the third question. So here one of the concept is that by using the 4 to 1 mux, okay, by using 4 to 1 mux, by using 4 to 1 mux, okay, by using 4 to 1 mux, we will get any two variable expression, as an output. Okay, okay, any two variable expression as an output, and sum of the three variable variable expression at the output by using the 4 to 1 mux. If we are using the 4 to 1 mux like this, okay, this is I0, I1, I2, okay, this is I2, this is I3, and this is S1, and this is S0, and if we have written here A and the B, so we will get any variable expression using the by 4 to 1 mux, we will get any two variable expression at the output, okay, at the out. So we will get here any function of the A and the B, any function of the two variable input, okay. We can get here 0, 1, A bar B, A B bar, okay, means any expression that will be the two variable. We can get here A bar B, we can get here A B bar, we can get here A XOR B, A XOR B, okay, we can get here A B, okay. So any expression we can get here we can get here A bar B bar. So any expression for the two variable we will get by using the 4 to 1 mux, and some of the three variable we will going to get. How we are going to get some of the three variable? When we are providing here the function of the C, so here the output will be present as the function of S. When we are providing the C, then the output will be present as the function of A, B and the C. So here all the three variable expression we are not going to find at the output by using the 4 to 1 mux. So if so similarly, so for 4 to 1 mux we are going to get the expression for the any two variable expression as an output, okay. If we are provided, okay, 4 to 1 mux, 4 to 1 mux, okay, 4 to 1 mux and plus 1 not gate and plus 1 not gate, we are going to get any, okay, 1 mux, 4 to 1 mux and plus 1 not gate we are provided, then we are going to find any two variable expression and any three variable expression at the output, okay, any three variable. By using only a simple NOT gate, we are going to find any three variable expression at the output. Now similarly, by using 8 to 1 mux, we are going to get any, okay, any three variable expression in the output logic expression, okay, and we will get sum of 4 variable expression at the output, okay. We will get any three variable expression using the 8 to 1 mux and some of the 4 variable expression at the output. But when we are using the 8 to 1 mux, when we are using 8 to 1 mux plus 1 not gate, we will get any three variable or and any 4 variable expression at the output, okay. So when the 4 to 1 mux is given, so we will get any two variable expression at the output and some of the three variable expression at the output. But when we are provided with the 4 to 1 mux plus 1 not gate, we will get any two variable expression at the output and any three variable expression, okay, at the output. Using 8 to 1 mux, we are going to get any three variable expression at the output or some of the 4 variable expression at the output. But if we are provided with the 8 to 1 mux and 1 not gate, then we will get any three variable expression at the output and any 4 variable expression at the output, okay. Now if we are given with 2 to power, okay, and we are given with 2 to power n ratio 1 mux, then we will find any any, we will find any n variable, any, then we will find any n variable, then then we will find any n variable expression at the output, okay, and the sum of n when n 2 to power n one given the any three variable, okay, okay, right. So we will going to find any n variable expression at the output, okay, at the output, or if we are going to find the n variable expression, we will take it in the opposite way. We will take it in the opposite way for finding any n variable expression at the output, okay, for finding any n variable expression at output, we require 2 to power 1 n 2 to power n to 1 mux, or we require 2 to power n minus 1 mux plus 1 not gate. See here, for finding the any two variable expression, we require we can find any two variable expression by using 4 to 1 mux, and we will write here 4 to 1 mux as a 2 to power 2 to 1 mux, right? And we will get some of the three variable by using 4 to 1 mux. For finding any two variable expression, we will find this by using the 4 to 1 mux, or any three variable expression we will find by using one NOT gate with the 4 to 1 mux. So if anyone will give you a 8 to 1 mux, and he will ask that how many variable we will find at the output, logical expression. In the logical expression in the output, how many variable will be present? So we can say that any three variable will be present at the output, in the any three variable present in the Boolean expression of the output, or some of the four variable also present, okay. Similarly, if we are going to find the Boolean expression, okay, for the output, okay, as a n variable, that n variable present in the Boolean expressions, then we require 2 to power n to 1 mux, or we can also do the same things by using 2 to power n minus 1 to 2 to power n minus 1 mux and plus 1 not gate, okay. And this is the very important, sometimes it's asked into the various test series. So if we are going to score the good in the test series, we have to clear this all type of the doubt. For finding the n variable expression, how much mux is required. So we require 2 to power n to 1 mux, or 2 to power n minus 1 mux plus 1 not gate, okay, plus 1 not gate. So almost I have covered all the topic, okay. In this I will have left only one topic, how we are using the multiplexer as a universal gate. So this as a universal circuit, this things I have left only one topic here in the mux, and I hope we will be covered. You are going to cover this topic, that how mux can be used as a universal logic circuit, okay. This topic do by yourself, and if you have any problem in this topic, please feel free to okay, please feel free to contact me on the Telegram group, okay. Post your doubt in the Telegram group, okay. Thank you.